You know, there's a lot of talk about climate change and sustainability and all that kind of good stuff, but if you look at the title of my slide, there's an extraneous word in there because we cannot do sustainable geotechnical engineering. That's too focused. If we're going to be sustainable, we need to think of the bigger picture. Thank you, sir. And the geotechnical engineering, we can do designs of geotechnical elements that are sustainable by themselves, like we're doing using less concrete, coming up with and using lightweight fill or something like that. But you have to think about it in the total context of the system. We need to be thinking about systems engineering. Geotechnical engineers are just one part of the entire system of engineers and specialists and scientists and policymakers that help us with developing a sustainable system. It's not just design. It's not just construction. We have to think about the environmental impacts, the impacts to society. What are the maintenance implications? Safety, operations. There's a whole bunch that are not listed here because you can think of them yourself. There's every little piece that goes into developing an engineered system. Because although I get hired as a geotechnical engineer and they say, Stan, we want you to turn this line on a paper that a civil drew into a retaining wall. But really, that's not the objective of the project. The project objective is to transport people from A to B, and they want to build a roadway along the way. So that retaining wall is a small part of the overall system. Well, and if that system, we'll use a highway as an example, goes through an urban environment, well, the less land we use might benefit something else. It might benefit the neighborhood by not having to destroy houses or take down buildings, or leaving green space available for other uses, or eliminating impacts to fish or wetlands. And so by looking at the overall system, we can contribute through geotechnical engineering to help the overall project and to work with our other specialties that are on it as a collective. And it's been my experience, observation over the last 40 years of my career, that we in civil engineering in particular, I'm just use civil engineering because that's my field, have advanced ourselves so that we think of ourselves not as civil engineers, but as geotechnical engineers, or hydraulics engineers, or structural engineers, or whatever our specialty is. And we have separated and piecemealed the thought process of developing a solution. When in order to develop a truly sustainable solution, we all need to be coming together as one. And like it or not, we should be overstepping our bounds as geotechnical specialists and interfering with the structural engineers and the hydraulics engineers side of the equation to make sure that they're considering things that we know from our own experience on other projects, because we all have different backgrounds and different experiences, and we can all contribute even though I'm supposed to stay in my lane as a geotechnical engineer. That does not work if we want to be and develop sustainable systems for the work that we do. And so I'm going to use reinforced soil as an example of where we can become more sustainable in geotechnical engineering in particular, but also to illustrate some of the systems engineering approach just using reinforced soil. But first, I'm going to do an illustration, a magic trick. Some of you guys may not be familiar with reinforcement geosynthetics. I'm hopeful that you all are. But with this very simple piece of material, I'm going to show you something that's just absolutely remarkable. Okay? If I push on it, it doesn't do anything for me. If I pull on it, it goes into tension and is very strong. And if I orient it in the right direction, I can pull on it and it's even stronger. Okay? These are fundamentals of materials. And we, as civil engineers and geotechnical engineers, I think, have failed to progress in our educational system to get beyond talking about just dirt. We talk about soil, we learn all about soil, we learn about triaxial tests, shear tests, all that kind of stuff. When was the last time you talked to anybody about concrete without the word reinforced in front of it? Reinforced concrete is fundamental to civil engineering. And reinforced concrete is a sustainable material. Why? Because without the reinforcement, we would use a lot more concrete. Okay, let's think about that. Without the reinforcement, we would still be building gravity concrete retaining walls instead of cantilever concrete retaining walls. We would be building bridges that look like the Roman style because everything had to stay in compression instead of post-tension beams that are very narrow and can span long distances. And it's the same thing that we can do with reinforced soil. Instead of building embankments, they are reinforced earth structures. If we think of them as structures, it's fundamental to civil engineering to think that it is engineered and designed. So if we stick reinforcement in to impose the tensile component, just like rebar does for concrete, we put reinforcement in soil to provide the tensile component that then the compressive component of soil can be leveraged. We can build steeper slopes on these reinforced structures. And by building steeper slopes, we use less land. We import less material. We can construct it faster. All of these have sustainable implications for them. We also get better performance. We have better resiliency of the slopes themselves. They don't slough as much. They don't have to be maintained the same way. And that applies for the slopes of a tall embankment, of a levee system. This figure on the wall, on the slide here, is a levee system that we developed and had constructed a few years ago. We put in base reinforcement that had multiple functions. It helped facilitate construction. It reduced the impacts to the adjacent wetlands. It allowed us to build a haul road that required a lot less maintenance during construction. We actually required the contractor to build this haul road instead of leaving it up to the contractor to build it and have the rutting and the repairs and all the worksite issues that they normally would have. We had reinforced slopes because not only could we construct them steeper, but it addressed the rapid drawdown issues associated with face instability in a levee system. We had reinforcement underneath the gravel surfacing section and under the pavement on another project because it helps the performance of the pavements. And we need to get this reinforcement aspects of geosynthetics and steel reinforcement when it's applicable and appropriate, integrated into fundamental education in geotechnical engineering. Reinforcement of soil is integral to the use of soil for earth structures, just as reinforced steel is for concrete structures. And Mr. Wilson was speaking earlier today about the gumbo soils in Louisiana. And they built the embankments using those materials. If we're going to build new embankments in Louisiana, we should be reinforcing them, because there is nothing wrong with using that soil if you use the engineering properties of the soil, combine it with the engineering properties of the reinforcement, and you end up with a designed, engineered system to meet the objectives, and it's more sustainable in the long term because of the redundancy built into it that helps offset some of the environmental effects of wetting, drying load cycles. The same goes for the freezing thawing effects in areas where we may not be in permafrost areas all the time, but the slopes of roadways fail and yield and creep due to the cycles of freezing and thawing as well. And putting reinforcement in there can help on that. And the pavement sections as well. Tomorrow, the PEC lecture is going to be talking about reinforcement and geosynthetics in the slopes and in pavement sections. Highly recommend it. And there is a multitude of papers out there on all of these topics, and we need to integrate reinforcement of soil into the fundamental part of geotechnical education. Thank you very much.